Today we're going to be talking about percent mass. This is a very common thing that we use in chemistry to determine what particular compound we're dealing with. Um, you end up getting data from various sources experimentally, and then from that you're able to kind of backtrack and you're able to get the formula for it, and we'll be learning how to do that coming up in another few months, but right now we're just going to talk about how we determine percent mass and how we get that from using the periodic table and data that we've been given. So essentially the idea behind this is that percent mass is going to equal the mass of an element divided by the mass of a compound. And if you think about this in terms of like math, that comes down to part over the whole. And we have a lot of things in chemistry that we do part over the whole. So typically when I introduce this, I usually have a class of about 25, 30 people. And what I'll do is I'll end up having people say what class they're in, freshman, sophomore, junior, senior. And then we'll take the number of freshmen and divide that by the number of people in the class times 100, and then that tells us the percent of each of the grades in our class. So we're able to kind of look at that and figure out the mass or the percent of each of those elements. So down here, we have an example where we have sucrose, and sucrose is a sugar that appears in various forms. Most commonly where you've had this is sugar at home that you use to make cookies or add it to your coffee or something of that nature. So when you go to the store and you buy sugar and it's in those like 4-pound, 5-pound bags, this is the stuff that you're getting is sucrose. So here they analyzed it. They determined that 8.44 grams of carbon were in there. They had 1.3 grams of hydrogen and 10.26 grams of oxygen. And they added all of these up to get the whole, and then they took each part and divided it by that whole and then multiplied by 100. So you can see here the math involved with that. So if we had, for our first problem here, we've got 78 grams of an unknown substance. So that's going to be our whole. And this is going to be our part. Okay, so we're trying to figure out the mass of the hydrogen in there. There's other stuff in there too. We just don't know what that is, but they're only asking us to be concerned with the hydrogen. So that's really the only part that we need to know about as long as we have the whole amount. So 12.4 is our part. We're going to divide it by our whole amount, which is 78.0. And then we're going to multiply that by 100. 12.4, 78, and so we end up with 15.897. So we're going to round that to the hundredths place. So we go 15 point, and that would end up being 90%. Our next problem here, here we're given hydrogen. They're giving us the amount of that, and they're giving us the amount of fluorine, and they're asking us what percent by mass the hydrogen would be in that compound. So here they've given us the two parts, but they haven't given us the whole. So what we can do is we can take these two parts and we can add them together, and that'll give us our whole. So we're trying to figure out for hydrogen here. We put 1.0, and then we're going to add the two parts together to get the whole. So that's 20.0 and times 100. And put that in your calculator. And you should end up with 5%. And that's going to be hydrogen. Now, you can do the same thing for the 19. If you wanted to figure out the percent for fluorine, you can do the same thing for the fluorine. You could put 19/20. Or since there's only two things here, you could also subtract this 5% from 100, and then that would give you your percent fluorine. It would be 95% fluorine by mass. Okay? So let's look at our next problem. Here we have 3.5 grams of X combining with 10.5 grams of Y. It's forming XY. What's the percent by mass of the X and of the Y? So here again, they're giving us two parts. If we add these two parts together, that's going to give us our whole. So we end up having, for X, we would have 3.5 grams of X over the total amount, which would be 14 grams. Times 100. And that ends up being 25%. That's percent X. So your units on this are going to be the percent sign and whatever element you're working with behind that. I always usually take this to the hundredths place. Again, you can put 10.5 over 14 and come up with 75%, or since there's only two things involved here, you could just take this 25% and subtract that from 100, and that would give you your 75% Y. 75% Y. And really, if we wanted to do that to the hundredths place, we probably should write it out properly. So 75.00% Y. Okay. Down here, we have two unknown compounds we're testing. Compound 1 contains 15 grams of hydrogen and 120 grams of oxygen. Compound 2 has 2 grams of hydrogen and 32 grams of oxygen. They want to know if they're the same thing and why. So if we look at our parts over the whole, the first one, if we look at the hydrogen, we could do 15.0 over, and our whole amount would be 135 times 100, and that's going to give us our percent hydrogen. So that's compound 2. If we look at compound 1, if we look at compound 2, we have 2.0 divided by 34, because our total amount would be 34. And that's going to give us our percent hydrogen here. Okay. So 15 divided by 135, that's 11.1%. And the other one, we have 2 divided by 34. That is going to be 5.88%. Oops, I should switch colors, shouldn't I? Sorry. Keep things consistent. So 5.88% hydrogen. Okay. So they want to know if they're the same compound. Since they don't have the same percent hydrogen in them, they're not the same compound. Down here, all we know about two unknown compounds is that they have the same percent by mass of carbon. With only that information, can we say that they are the same? I would say no, simply because when we're looking at these, we could have other compounds in there. So we could have, we could have a kind of a pie here where we had 25% of that was hydrogen, let's say, and the other part was carbon. Or we could have the same here, where we had 75% carbon over there. So the carbon was 75%, and that was hydrogen. What if we had another one that was 75% carbon, but it was a completely different element, like oxygen? So just because we know that the carbon is the same doesn't mean that the compounds would be the same. All right, the next one is percent composition of an actual compound. So this is, we're going to give you a compound and we're going to ask you the percent composition for each element. And there's some steps involved in this. It's still the part over the whole, but I'm going to show you how to get that information off of the periodic table. So what you do is you start out with a particular compound. In this case, we're working with glucose. You should have seen this probably in a biology class along the way. And with this one, we've got carbon, we have hydrogen, and we have oxygen. So the first thing that you're going to do is you're going to make a list of each of the elements. So you write down carbon, hydrogen, oxygen. Then you are going to write down how many of each element you have. So for carbon, we had 6, hydrogen, we had 12, and oxygen, we had 6. We use these subscripts to determine that. If there's not a subscript present, then that means that it's only 1. Then what we do is we will take that mass off of the periodic table, and we will write that, we'll write times, and we're going to take the mass off the periodic table. The mass off the periodic table, take that to the 10th place. So you're going to round that to the 10th place. So for carbon, that would be 12. For hydrogen, it would be 1.0. And for oxygen, it's 15.99999. That rounds up to 16.0 when we put it to the 10th place. So 6 times 12 is 72. 12 times 1 is 12, and 6 times 16 is 96. The next step is we add up all of these masses, and that becomes our whole. So then we take the part and we divide it by that whole amount. Multiply by 100, and that's going to give us our percent composition. So finish typing that out. Your units end up being percent, and then whatever element we're working with. Okay? So let's try that for a couple of these. The next one that we're going to work with is sodium chloride. Again, if we don't see subscripts, we assume that there's 1 in there. So here's our sodium. We have 1 of those. And our chlorine, we also have 1 of those. Take the masses off the periodic table. For sodium, it's 23.0. For chlorine, it is 35.5. Oops, there we go. And multiply those out. Oh, I'm getting my decimals all out of the whack. And then 35.5, add those together. We get 58.5. Then we're going to take our part over the whole. So 23 over 58.5 and 35.5 over 58.5. Then we multiply those by 100. And we'll be able to get our percent composition for this. So 23 divided by 58.5, we end up with 39.32%. And that's percent sodium. Again, your label is the percent sign and the element we're working with. And this one ends up being 60.68%. And that's chlorine. Now, as a good double check, you should always add these up at the end, and they should come out to be about 100. Okay, if they don't, then you mess something up. The next one then is, this is actually hydrogen peroxide. You may have used that on some of your cuts. Some people use it to rinse their mouth out. Don't ever drink it, though. It will make you sick to your stomach. We have 2 hydrogens at 1.0 each. We have 2 oxygens at 16.0 each. So that gives us 32.0 for our oxygens and 2.0 for our hydrogens. Then we are going to add those together, so they add up to be 34. And we're going to take our part over our whole. So this one ends up being 5.88% hydrogen. And this is 94.12. And that's going to be percent oxygen. And again, add these up, make sure that they add up to be 100. All right, the last one we're going to do that I'm going to talk to you about how to do these is ones that have parentheses. And we'll learn when we need to use parentheses later on in the semester when we get to writing out the formulas for these. But right now we're going to be just looking at the percent composition. So just like in math, when you have parentheses, you end up multiplying to distribute that 2 out. We do the same thing here. So when we're doing our inventories here of our different elements, we have barium, we have carbon, we have hydrogen, and we have oxygen. And we need to figure out how many each one we have. So this is outside the parentheses. There's no subscripts here, so there's only going to be 1 of those. For our carbon, we need to distribute. So 2 times 2 is 4. For our hydrogen, it's 2 times 3. so that's 6. And for our oxygen, 2 times 2 is 4. Then we go back to our periodic table and we find out our masses for our barium, which that one is 137.3. Carbon is 12.0. Hydrogen is 1.0. And oxygen is 16.0. So for our barium, that's 137.3. For our carbon, it ends up being 48.0. For our hydrogen, it's 6.0. And for our oxygen, it's going to be 64.0. 4 didn't come out real well. That almost looks like a 9. Try that again. There we go. All right, so we're going to multiply these, or we're going to divide by the total of all of these. So we've got to add all of these up. So let's take 137.33. We have our 48, our 6 from our hydrogen, and our 64, and that's 125.3. I'm sorry, 255.3. 255.3. And multiply by 100. Okay. So the first one ends up being 53.79, and that's percent barium. Next one is 18.80. That's percent carbon. .35. That is percent hydrogen. And 25.07. And that is percent oxygen. So that's how we do percent comp when we're giving information off of the periodic table and given a formula. The next part is law of multiple proportions, and all this is stating is it's very similar to the one that we did up here where we looked to see if we were dealing with the same compound or not, for this one and for this one. So here, since they had different amounts of or different percentages of hydrogen and it didn't end up being the same compound, we're looking at the same thing down here. So law of multiple proportions, anytime you have multiple proportions of something out there, that means that you've got different compounds. Okay, so if we complete this table down here, we're going to figure out what our different masses are and see if these are the same compounds or not. So here's our total mass. Here's the mass of the iron. So if we have the mass of the iron and the total mass, if we subtract this from this, that'll give us our mass of our oxygen. So 75 minus 52.46. That means that the oxygen is going to be 22.54. And if we divide that by 75, we end up with 30.05% oxygen. So for that one, what we're going to do is we're going to take this value and divide it by 75. So 52.46 divided by 75, we end up with 69.95. So then over here, we've got our total amount and our amount of oxygen. So 56 minus 12.47, that ends up being 43.53. We take that and divide it by 56, then we end up with a percent composition for our iron of 77.73%. 3. So without even doing this last one, we can tell that they're not the same compounds because they don't have the same percent of iron. But we can finish that out. We have 12.47 divided by 56. That means that our oxygen is going to be 22.27% oxygen. Okay, so if they don't match up, if they don't have the same percentages in them, they're not the same compounds.